Hello and welcome to your first wet lab in Chemistry 111. This first lab is Lab 1, Density, relating mass and volume. Density compares the mass of an object to its volume, and density is the mass of a substance divided by its volume. We have the density expression here. In the density expression, we take the mass that we would have measured in the lab, the volume that we measured in the lab, divide the mass by the volume, and we'll get this property called density. What's interesting about density is mass is what's called an extensive property. So there's no limit except what you can afford to how much you can have. So you could have as much gold as you could afford, and that gold would occupy however much volume of gold you could afford, but the mass of that gold divided by its volume is unique for gold. So I want you to note that the units could be grams per milliliter or grams per centimeter cubed because 1 milliliter is equal to 1 centimeter cubed. Here are some densities of some common substances. And I'll have you note water, everything is tied to water here, with water having a density of 1 gram per milliliter at 4 degrees C. At normal temperature, so around room temperature, it's close to 1, but not exactly 1. And for most normal temperatures, it's relatively close to 1, although again, not exactly 1.00. Cork is a real common demonstration that we do. Cork is a very has a very small density, and therefore cork will float on water. Gasoline will float on water. Olive oil will float on water. How can I tell that? Because all these numbers that have been measured for their densities are smaller than 1. And then here's a few things that will sink in water. So liquid mercury would sink in water. Here are some other metals, silver, lead, and gold. Those would all sink in water. However, I want to bring your attention also to the gases here. Notice that the unit has changed from grams per milliliter to grams per liter. We usually measure gases in grams per liter because their densities are so small, it's more convenient. And so all of these are very tiny compared to water. And so all of these different gases, if you were to put them in water, would bubble to the surface. All right, here's a demo. We have water as our liquid that's in this beaker. And then we have ice. Very interestingly, ice is less dense than water. It's important in nature. This means that what happens is in wintertime in lakes, they freeze from the top and not from the bottom and freeze solid. So they crust up on the top because as ice forms, it moves to the top, and then we form a crust of ice on the top. Cork, as we said earlier, is less dense than water, so it floats. And our two metals here, aluminum and lead, both sink to the bottom because they're more dense than water. What are we going to do today? You're going to measure the masses, and to do that, you're simply going to put your samples onto an electronic balance. We should talk a little bit more about how we're going to measure the volume. We can use this process called measuring volume by displacement. Here on the left-hand side, we have water, and we've added a bit of blue dye just to make it more easy to visualize, and we've added 35.5 mLs of water to the graduated cylinder. And we slowly and carefully, because this is heavy, slowly slide in the metal, try not to get it to splash. Then we would go in and we would tap it, make sure we don't have any bubbles adhering. And finally, after we're satisfied, we would measure a volume of 45.0 mLs. And so the volume here on the right-hand side is the volume of the water that was already there, 35.5 mLs, plus an additional 9.5 mLs from the added zinc rod that we've added in. Okay, and we've had to assume that this is solid zinc. There's not holes or pores or anything like that that are in the zinc rod, and therefore, if that is all true, then the volume of the zinc rod is 9.5 centimeters cubed, or milliliters. As far as how to figure out the mass, that's going to be easier. You're going to put on a weighing boat. That's a plastic container that's sitting here, just simply so our samples aren't directly on the balance. You would put that on and you would zero the balance. Once you've zeroed the balance, add in the zinc rod, and when doing that carefully, we find out that the mass of that zinc rod is 68.60 grams. Now we can calculate the density. The density is equal to mass over volume. The mass is 68.60 grams. The volume is 9.5 centimeters cubed. And so we can only here claim two significant figures because the volume is only measured to two significant figures. So our calculated density here is 9.2 grams per centimeters cubed. All right, now let's get to our specific lab today. Everyone will work in pairs today for this lab. Each sample should be weighed once on the electronic balance, and then the volume should be determined 3 times. You may wonder, how can you determine the volume 3 times? Well, you'd go through the process of putting some amount of water into your graduated cylinder, slowly adding in your metal, tapping it to make sure we don't have any air bubbles, measuring the volume, pouring out your water, tapping your metal dry with a paper towel, and then repeating the process 2 more times to get an average volume. And your volumes should be read on the graduated cylinder to the nearest 0.1 mLs. Remember, again, we can estimate 1 digit between the lines that are marked on the graduated cylinder. All right, some lab groups will have scenario on the left, some will have the scenario on the right. If you have metal shot, and metal shot look like these sort of malformed beads, they come from taking the hot metal and dropping it into water. And the metal shot, you will use the 10 ml graduated cylinder for your volume determinations. If you have the washers are, because of their shape, are too big to fit into the 10 ml graduated cylinder, and therefore you will use the 25 ml graduated cylinder. As far as safety, this is a wet lab, and all of us, including myself, your lab instructor, anyone that comes in the room needs to wear lab coat, lab clothes, shoes, safety goggles, and a lab coat. You need to take your safety goggles off. You need to go to the hallway first to wipe them down or anything like that, but you cannot take them off while you're in the lab room and chemicals are being used. All students should wear their safety goggles over their eyes, not over their foreheads, not over their necks, not sitting on the desk. Everyone wears lab coats and goggles until all groups have put away all equipment. At that point, when all groups put away all equipment, you can sit down at the benches in the lab and everyone can take off their goggles. Students should keep their bags on the shelves below the whiteboard. We do this as a tripping hazard in case there was a fire. In the lab today, you'll plot your data using the Logger Pro software on the laptop computers and show your graph to your lab instructor so they can initial your data sheet. You're going to do all of the post-lab questions 1 through 4. I encourage you to look at the questions and think about them a bit before you write your answers, but it's fine to talk to the people that are around you. But I would ask that you think a bit independently, and then when you answer them, you want to answer them in coherent, clear, complete sentences. In general, you'll turn in your lab report at the end of the lab period. Write down the name of your lab partner on your lab report. As far as waste disposal, you'll return your quote-unquote used solid samples to the appropriate recovery beaker. The lab staff will come in later, dry those samples, and we'll use them in a subsequent lab period. Proper waste disposal is always important. It's important here because we want to recycle these. These metals are expensive, and we want to keep as much of them as we can to recycle each time.